So this is pretty much everything that's going to be on the exam, pretty much, give or take. So you should be familiar with it. Oh, I forgot one more. Okay, and you guys remember you have until Tuesday to complete the exam. And then remember the next exam is going to open up on Friday. So it's just going to be, okay, because we're almost done. And I'm hearing rumors that, you know, you guys don't have class here, or you guys do have class here. You don't? Those rumors are true? Okay, fortunately for you guys all have computers. That isn't true for this class, right? So I will see you guys online. We'll all be online. We'll be turning it up for about an hour and a half on Monday. Yeah, at 1. So you don't have class Friday? I have no idea what you guys do here. I mean, we don't have class with me on Friday. So what do you guys normally do on Fridays? Okay, don't come on Monday, but come online on Monday. Yeah, yeah. Jessica, you know you're not going to get up at 7, so don't make that. So do you want to share that online too with the other classes?
For everyone else, NDC, Kalinga, can you hear me? I'll send an email about this, but I'll be having upgrade session on Monday from 10 to 1, but I'll send an email with more information.
Okay, so there's probably 5 other things that I'm missing, maybe 20. I can't remember. It'll be in one of these chapters. So look over the chapters to be sure. Make sure you know everything and you'll be okay, right? Piece of cake? Okay, good. So I'm going to start off with just a couple of things that are dear to my heart. So to make sure that you guys make sure you know how to do this, right? So like, for instance, I like giving questions like this. Yep, sorry, let's do this. Yes, I can. Yes? No. Because I can't cut into her. She has so many hours that she can give me. I can't make her do more hours than she's doing. I don't know. I mean, I think she's not here Fridays. I think you guys are here because you guys, your days are shifted. So you guys, don't you go to school Monday, Tuesday, Wednesday, Thursday? Uh-huh. So what we'll do is we won't make you come Friday because it's already being taken care of because you guys are going to be in lecture that day. Okay, so you'll be okay. So you don't have to come for my class. Yeah, I just have to let your boss, you let Mrs. Grunick know. So. Okay. Okay, while you guys are checking your planner, let's see, if calcium chloride reacts with ammonium phosphate, it produces a phosphate precipitant and another aqueous compound. Write the balanced chemical equation. Okay, so what do I need to do? Okay, what are my reactants? So calcium chloride and ammonium phosphate. Okay, so how would I write that? Ca Cl. Can you guys hear me on the other side? Because it says my audio is messing up.
Yeah, we can hear you.
So it's CaCl. I should say solution. So if I have solutions here, what am I going to put? That's the abbreviation for solutions. So what would I put if it's a solution? AQ. And what else? What is the other reactant? You said PO, PO4, NH2, NH4, does that balance out? Wait, is this a balanced chemical formula? No. So is that good to go? No. So what do I need to do to make it balanced? I need 3 ammonias. Okay. Okay. And then what is that going to make? What type of reaction is this? This is an acid-base reaction? What type of reaction is this? Okay. A double replacement reaction. Okay. What was that? What was the question? Double replacement reaction. So what should be my products? And you said, so which one do I put first? Na. Oh, sorry. NH4. Okay, I'm going to ask you, is this right so far? Are you sure? I need parentheses for what? The NH? Okay. So do I need parentheses? What is the charge on NH4? Just one positive? Okay, so it's just one positive. And what is the charge on Cl? A -1. So if I have a +1 and a -1, do that add up? So do I need parentheses? No. Okay, what about the very first one? Calcium phosphate. Is that balanced? Are you sure? What is the charge of calcium? It's +2. Okay, and phosphate? It's a -3. So you guys are telling me 2 minus 3 is 0. I need to add another what? I need another calcium, so I need 2 calciums. Is that what you're saying? Are you sure I need 2 calciums? Okay, so let me make sure I understand this. I just want to make sure that I understand, I'm getting old and I'm getting hard of hearing, but you guys told me that calcium was a 2+, right? Isn't that what I heard? Okay, and you told me that a phosphate is a -3. I need 1 more calcium. So you're saying what was that again? 3 calciums. We need 3 calciums and 2 phosphates. Okay, let me fix that. Hey, this is not church. I say, hey, this is not church. This is chemistry. Jesus is not here right now. Okay. Calcium phosphate. Are we good? Is there anything else I need to add? Isn't there something that was given to us? Are we going to put aqueous? Because it says it produces a phosphate precipitant and another aqueous solution. So what should be the aqueous should be on? Shouldn't it be here? Okay, so what should be on that phosphate compound? What does precipitate mean? I know, but it's misused in that context. Yeah, yeah, that's all right. It's a solid. A precipitant means a solid. So we'll put an S here. Okay, so in theory, this would be that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8 points that would be available for this question. Now we need to balance it, right? So technically that's 8 points, technically already just writing it out. How many more do you think with balancing it? Is it balanced? Those be like 10 to 15 points. So this question here could cost you 10 or 15 points. Then guess what? It's wrong. Okay, so is it balanced? Okay, so how do we go through that process of balancing again? I know it's been decades since we did it. Break them down. So I can keep them together too, right? You're telling me? Oh, I like that. So you're saying that I can do this? I just want to be sure. Because they're a family, that's right. So I could do this. And I can do this. Okay, on my reactant side, how many? There's 1, there's 2, and then there's 3, and there's 1. Okay, on my product side. Okay, is it balanced? Okay, what do I need to do to balance it? Put a 3 here. So then that gives me 3, this gives me 6. Okay. Six here or 6 here? On the product side, okay. Okay. And how many chlorines do I have? I put it on the wrong side. Are you sure I put it on the wrong side? Okay. You said 3 here? A 2. Okay, so is that balanced? Piece of cake, right? Nothing that you guys haven't done before, right? Good. Yes, sir. So that would have been the easiest 20 points that you could have had, right? No, are you crazy? Do I put anything exactly the same? Maybe a little bit, huh? Just a little bit. Okay. Okay, so you guys have an idea of what to expect. You're feeling it, right? And so of course you're gonna have your practice test. You're gonna have a couple of these to practice on. Well, you better learn. You have a few days, so you better hook up with the tutors and you know, utilize those skills, talk to your classmates, you know, because hey, we've been doing it since the very beginning, right? So at this point, you should really have a good grasp. That's right. Yeah, you're almost to that point where you almost can. We're working on it. We're getting you guys there. You know, after the end of next week, then you guys are almost ready for that entry level in a chemistry lab, an internship, right? And then at the end of that one, then you should be ready for the entry level, working for it. Well, you need to come in with something, because if you come in with nothing, then it's a lot harder. You're putting a lot of work on the individual. They usually if you work in a chemistry lab, you'll be making solutions, right? So the first thing that you have to do is be able to find the chemical that you should be looking for, right? To make a solution. Don't worry, you guys are going to make a lot of solutions. You'll be making some next week, so it'll be fun. You'll love it. It's the same thing that you guys are doing, you know, essentially, like what you guys have done in lab, you know, the experiments and stuff. That's right. And so, but it really depends on the type of lab. So let me repeat your question so that the other side knows what we're talking about. So they want to have an idea, what is it like to work in like an industry as a chemist, right? That's the question, right? So it depends on the type of lab that you work in, right? So we have what we call R&D, research and development. So there you do a lot of experimentations. It's not random. You have an idea, you set up a hypothesis, you go through that whole process, and then you test that hypothesis by mixing different formulations of a chemical compound or a chemical solutions. So in my situation, since I was working on living organisms, that's a little different. So we did chemical solutions all the time. We always made chemical solutions, 90% of the time. So, but what we were looking at how the virus would actually infect cells, or they would infect an individual. So what we did, we took blood samples from individuals, right? And we kind of mimicked their viral load, how much virus they had in their body in a cell culture, and to see how much drugs, if we gave these drugs, would these viruses become resistant to those drugs at different levels? Yes, which it did, because it meant that if a patient is not taking their drugs appropriately, right? They're not taking the way they're supposed to, there is a high probability that they would become resistant because it's not killing enough of the virus. Not always. There's going to be a basal level of viral load in the case of HIV patients, right? So there's a small level of it. It's called undetectable. And when it's undetectable, it's hard for the virus to infect anybody else, but it's still there, it still exists. Okay, the way that we use chemistry is because we use that concept of the drugs and where that drug is attacking and how it changes when you have with the virus, exactly. Yeah, and so because the virus makes changes in itself, that's right. Yeah, and so then that's how chemistry is used in that context. But in the context of living organisms, there's a lot of chemistry always involved in it. I was part of a project. I was a part of a team. So you know that whole concept of the group project. I'm talking from experience, right? So I was the head researcher for that group, but I still had to report into somebody else, right? And so my job was to make sure that everybody else was doing what they were supposed to. We would get together, we would talk about what was happening and what we believed was happening. And based upon what my team said, I would go back and I would present that in meetings and in conferences and things like that to say that, hey, we're right on this, or hey, we were way wrong on this, right? At the end of the day, No, we would have to come up with the hypothesis to test out. That's what the team is for. And so it's like, even though that I was in charge of the team, we worked as a team. So everybody was contributing. That's kind of like what you guys are going to be doing with the group project. Our bosses. So there's always somebody above you, right? So it's not like, yeah, think about it. I come from a poor family. I did not become independently wealthy overnight, right? Not to say that I'm independently wealthy. Exactly. So there's always somebody to answer to. You answer to the money. Exactly. Exactly. Yeah. So that's the way it works, though. You know, typically because it's the people with money. They're smart enough to pay people who don't. That they know they're not as smart as those people. They pay the smart people to sit there and do the jobs. So, okay. Okay. So let's back to chemistry. Let's not get too far because we got a lot more to cover. Okay, so are you guys feeling comfortable with this? Okay, so how are you guys feeling comfortable with nomenclature? Naming. Nomenclature means naming. What was that, Haley? I said, do you guys feel comfortable with nomenclature? Oh, it means naming. Naming compounds. Yeah. Yeah, naming compounds. Nomenclature is naming. It means naming. That's all it means. So it's inorganic nomenclature. It means naming inorganic compounds. Yeah. And then organic nomenclature means naming organic compounds. Okay. Where do you go for what? Of course. Because haven't we done, wait. Haven't we done both? Okay, I'm going to throw something at you here soon, right? Okay, can somebody tell them what we're talking about? Nomenclature, exactly. So now you want to make sure you understand how to name compounds, because if you can't name compounds, how can you set up a chemical equation, right? And then you also need to know the different types of equations, different types of chemical reactions. So what were the different types of chemical reactions? Oh, so you're saying double, single, is that double, single bond? Is that double, single? You've got to elaborate. Double, single reaction? Oh, double, single replacement reactions, okay. So in the double replacement reactions, what's happening? Simplest way of thinking about it. They're switching partners, swingers, exactly. Okay, we're switching partners, simplest way of thinking about it. What about a single replacement reaction? So you dump the old girlfriend for the new one, right? Okay, or a boyfriend, you know, depends. Okay, what about synthesis? They come together, okay? What about decomposition? Okay, they break apart, okay? And what about combustion? Oxygen and carbon dioxide mix? Isn't oxygen and a organic compound mixing? Because isn't it usually like propane or butane or, okay, that's right. It's also called organic oxidation, that's right. Okay, so you guys, you know that, right? Okay, if I say something is endothermic, what does that mean? Endothermic. It's like, so you're putting heat into the system? Oh, so it's kind of like we turn on the pot and we're turning on the heat. So the heat is going into the system, right? Okay, so endothermic is when you're putting heat in. What is exothermic? So when heat is being released, right? Okay, let's see. What else was it? There's something else that I knew there's. Oh, okay, so I'm just curious, right? Those Roman numerals. Okay, so I didn't even ask the question. So when do you use them? Obviously, when you're working with transitional metals or anything else? Any other types of metals or oids or anything like that? Yeah. So we of course, that was very general there. We're using them from nomenclature, but we're using them for, you guys said transitional metals. Is that it? Yes, post-transitional metals as well. That's right. What was that? And metalloids, and sometimes metalloids. That's right. Okay, so now, this is the one that always gets me, right? It always kind of throws me for a loop. So those Roman numerals, do they stand for the number of that compound that of that element we have, or does it stand for the charge? It stands for the charge. That is correct. Yes. You're gonna, what am I gonna say? No, P right there. No, I'm joking. Go to the bathroom. Okay, so any other things? Anything else that I missed? Anything else that I missed that you may want to know? Okay, Kalinga, Fireball, you guys know it's understood that I'm talking to all of you, right? Everybody knows that, right? Because I love you guys all evenly, or I lack of love of all you evenly, one or the other. I haven't decided yet. Yes, ma'am. We will talk about the extra credit. Don't worry about it. You will have another, well, not another opportunity extra credit, but another opportunity to do more nomenclature. That's what you guys are doing today for lab. So. Well, partially, yes, because I know it's difficult. The other part of it, and really, Diego, come here. I want you to sit right up here with me, right here in front of me. Yes, Diego, where's your mask? So now the reason why I give you guys the extra credit is because I know that you guys need a little push to do things, right? And like I said, I'm very competitive. I don't know if you guys can tell. You tell I'm competitive. And I look at it like this. You guys are representative of me. If you guys are a piece of crap, that makes me a piece of crap, right? No. I'm sorry. It is what you guys produce is what comes from me. If I don't give you 100, wait, hold on. If I don't give you 100%, right? Then how should I expect you to give 100% where you do, right? So I give you guys 100%, so I expect high expectations of you. So I want to make sure you guys know strong, you have a good foundation. Nomenclature, you have to have a good foundation of nomenclature, right? So you really need to know that very, very well. So that's the reason why I keep pushing you on it. And then the biggest thing, I hate it when I come in, when I have students that would come in and work for me, and they'd come in and they just finished taking chemistry, and they couldn't tell me what the fucking was, excuse my language, what was on the bottle, right? They couldn't tell me what was on the bottle of something that they were supposed to be working with, right? Or they were too scared to, oh, this is sodium chloride, or this is, you came in, you've taken this course, you should know this at this point. I shouldn't be teaching you what your teacher should have taught you, right? And so in a job situation, that person may be interning with me, right? Do you think I want to hire somebody who I know that isn't capable of doing what they should be doing when they come into the job? No, right? So I want to make sure that you guys don't have that problem. And if you do have that problem, that's on you, right? Because I've given you everything that I can give you, right? So you are a reflection of the environment, right? So if I give you a good foundation, then you guys, it makes our program looks good. People want to come, more people want to come to our program. Like currently, not to toot my own horn, we have students that are coming in from Fresno. We have students that are coming in from Los Banos. We have students coming from other places because our program is getting better, right? Our chemistry program, yes. Yeah, we're building up this little tiny program. Jessica's class was the second class. My first class of chemistry, I started out with 5 students, right? 5 students. It was 2 guys. It's funny. It was 3 guys and 2 girls. The second class was 9 girls and 1 guy, right? It was just, was it? Like, no, was it 2 guys? for 1A. Yeah, but that your class, that was for 2A, that was 20 people that was in that class. Yeah, and then 1B, yes. Yeah, that's because a lot of them don't have to take 1B. So yeah, so and then we lost all the guys for that, and it was all girls except for, was it Jesse was the only guy left? Yeah, yeah, yeah. So I had 9 women and 1 guy. Yeah, so it's changed over time, and that also that if you think about society, typically society-wise, this area is a little bit different. Well, no, I'm not saying that. No, I'm saying it's different because typically, if you look at the scientific community, it doesn't, you have more men, and typically you have more white men than anything else, right? And so here at Coalinga and Avenel, and there's a lot more women that are getting into the sciences, right? And so you guys are, the question is that typically this is the point. High school is where people make that decision whether or not they're going to stay in the sciences, particularly women. And a lot of women will get discouraged because they see that they're not reflected in that community. Guys often will talk to them as if they don't know anything. They're always talking down to them or talking at them, right? And so, exactly. And that is a valid point. So, okay, tell me your name again. Margarita. So Margarita says, I want to repeat this. She says, we can use that to our advantage. And you can use that to your advantage to a point. And then there's a point where you have to make sure that you're getting credit for work that you did. Okay. And so in the beginning, when you're getting your feet wet, use it to your advantage. Later on, you make sure that you get your credit. Okay. Because it's important that you guys get the credit that you do. Right. Okay. So you guys are feeling confident about chemistry. We have a lot of social issues that we talk about. We got to talk about them because I want you guys to be prepared for the real world. Part of it is social and part of it is academic. So we need both of those. Okay, so anything else? Anything else? Everybody's feeling comfortable? So let's say we had a number like this. Okay, as a scientist, I hate writing numbers like this all the time, right? These really, really big, huge numbers. Now you're gonna always be working with numbers that are always gonna be so huge, right? So as a scientist, we like to be lazy. So that's the reason why we like to use scientific notation. So we wanna make it simpler so that we can understand it. So we sit there and put it in this format. The way that we would do that is, right now, the decimal's right here. I count back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would give me that 1 digit, and then I have the number following it. Now you guys are all paying attention to this because I'm only going over it once. I feel like my mom in this class a lot of the time. Because she used to tell me, I'm going to tell you this one time. And if you don't listen this one time, I'm knock the shit out of you. That's what she used to tell me. No, she would tell me that you got one time, you got it. That's it. So, but I can't knock the crap out of you. I think about it, but I can't. So now the key is you want to make sure that you have all of the zeros taken into account. The zeros, again, are going to serve as space holders, right? So for instance, how many of you guys got $10? Like on you. Yeah, anybody got $10? Okay. Okay, hold on. Okay, whoever has $10, take it out. This is a 10. This is not a 10. $10 bill, right? This is $1. Right? Okay, thank you. Okay. Lesson for today, right? Okay, no, just kidding, just kidding. Okay, so now is 10 equal to $1? Okay, so if I don't have that space holder, right, then you're telling me if I did 10 and 1, those are two different things, right? So now we're going to talk about what we call significant figures. Both of these guys have one significant figure. 10 has one significant figure. 1 has one significant figure, right? Now, this is the hardest thing for students to understand for some reason. These zeros here are just space holders, right? They're letting us to know that this is $10. It's not $1, right? But significantly, we have one significant figure because we know that 1 is there. This one, we don't really know if it could be a 1, it could be a 0, it could be 9, it could be something, unless we know for sure. The way that we say that we know for sure is by putting a point here, right? A decimal. That tells me that I have two significant figures, right? If I don't have that decimal there, I assume that this number here, it could be 9 and we just round it up to 10. Or it could be actually 10, or it could be 10.001, or it could be, so we don't know what it is unless we sit there and let us know. So that's what a significant figures do, okay? And that's going to be the relevance of significant figures. So these zeros, these are important, right? Significant figures doesn't mean that they're not important, but these zeros here serves as space holders. They're just holding space to let us know that we have a really big number, kind of like the difference between the 1 and the 10. Now, 1, right? Right? Students, for some reason, they'll have a number that is billions and billions and billions, and I tell them that there's one figure. And then you know what they'll give me for the answer? 1, right? I'm asking them, I said, okay, so this answer is, 1 times 10 to the 27, right? So you're going to give me 1 times 10 to the 27. That is one significant figure. Where 1 times 10 to the 27, that is one significant figure, right? So a student will sit there and tell me, so the answer is this, 1 times 10 to the 27, they will give me 1. Are they the same thing? Okay, so that's kind of like me saying, okay, I owe you $1,000, right? Because you've done $1,000 worth of work and I pay you a penny, right? Is that the same thing? No. Would you be upset if somebody paid you a penny for $1,000? Okay, so you got to understand when we're talking about significant figures, you still need those zeros. They serve as placeholders, but they don't count as significant. Now, I'm going to explain to you this whole process, but first, I want you to understand this is scientific notation. When we're talking about the digits, the exponents don't count as significant figures. Okay? Yes. 1, 2, 5, 7, 3. That's 1, 2, 3, 4, 5 significant figures. Leading zeros are not heroes. Exactly. Leading zeros are not going to be significant. They only serve as space holders. Okay? And so that's the same thing that can be said about trailing zeros, right? I don't know about them not being heroes, but they're not heroes either. They're not counted as significant. Like in this case, we have 1, 2, 3, 4, 5 significant figures. These zeros are not significant. If we put a decimal here, what I'm saying by putting a decimal there, I'm saying that I'm sure that this 0 is a 0, right? By me putting that decimal there, it tells me that it's significant. If I follow it with another 0 here, I put decimal here, 0, 0, 0, 0, 0, 0, then this 0 is also significant. Because I'm saying, I'm taking the time to put this extra period at the 0, it becomes significant. Are you with me? You understand? So if I put a decimal here, it makes it significant. Yes, that is correct. So that tells me that all of these guys, so that means that I am sure about those zeros. That's what I'm telling you. Okay, so significant figures is about being sure about something. Okay, so that's really what it deals with. When there's some uncertainty, you guys know what uncertainty means? Not sure, right? So if I'm not sure about it, then I'm not going to put a decimal there because I'm not really sure if that's really a 0 or if it's or it's a 1 or if it's a my scale sucks, so I can't tell for sure, right? You guys have had some crappy scales, if I remember correctly, right? Okay, so let's start off with just scientific notation, right? At this point, you guys should be very clear with this. So if I tell you for this first one, rather than having you guys write the whole thing out, I want 3 significant figures and I want it written in scientific notation. How would you write that? Let me clear the screen so you'll see what I'm talking about. So convert 3,672,199 to scientific notation with 3 significant figures. Okay, so you told me you would put 3, what? $3.6 times 10 to the 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. Okay. So I said I wanted 3 significant figures. You gave me 3 significant figures. So this number here serves as a number that we're going to use to either round up or round down. If that number is greater than 5, we round up. If it's at 5 and there's numbers following it, we round up. If it's at 5 and there's no numbers following it, we leave it as it is, right? Or we leave the number before it as it is. If it's below that, we leave it as it is. No, you're not going to assume anything. I told you you're going to have 3 significant things. You got it? Yes. Well, you're taking into consideration, but this is a 2, so it's not going to make too much of a difference. So you're using this 2 to determine whether or not you're going to round the 7 up or you're going to leave it alone. Isn't it under 5? So then you're going to leave it alone, right? So the 7 stays as a 7. It's not going to be rounded up. Let's say we had a 5 here, right? So if we had a 5 here, then we'd round it up to 8. So then the answer would be 3.68 times 10 to the 6. Okay, so reality is, right? But it's something that is done in science. And it's funny because it depends on the level of science you're at. So 5 is breaking point. 5 is that in between point. If it's above 5, we always round up. If it's below 5, then we round down. 5 is that breaking point. 5 exactly, you would leave it alone, right? It sounds weird. If it's exactly at 5 and there's nothing following it, you're leaving it alone. If there's one little number way down there, that's pushing the scale over, right? So have you guys ever played seesaw? Have you ever been on a seesaw with somebody? Okay, so if a person weighs exactly the same amount as you, what happens? It balances out, right? It's exactly like you. If you weigh more than the person, what happens? You're going to go down, the person's going to go up. If you weigh less than the person, what's going to happen? Okay, so the way it works in science, We use that 5 as that breaking point. In reality, if you're just a little bit more, right, then you're going to go down, right? So if you're a little bit more, you're going to be rounding it, right? If you're a little bit less, you're going to be rounding it down. If you're right at that point, if it's perfect, you're going to round it down because it's uncertain. Okay. Okay, so, and don't worry about it, we'll do more of those in a second. Okay, here, how can I convert this into scientific notation? 3 sig figs. Are you sure? Are you sure? -3. There you go. Okay, so we want to count. We take the decimal, we count back 1, 2, 3, right? So then we have that one number, and then we have our decimal point, and we have our numbers. Keep it in that same format. Are we good? Yeah? Why do I go back? Okay. Okay, so if we have these numbers and we want to convert them into decimal form, so how would I go about doing that? So 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 4, 9. Okay. And what about this guy? Okay, questions, concerns? Okay, so the key is if it's positive, we're going to be getting a bigger number. So if the exponent is positive, it's going to be a big number. If the exponent is negative, we know it's going to be a really small number. First, let me bring my water. Okay, questions? No questions? Good. No, that was a little fluke. You're talking about this one right here. My pen gets away from me every once in a while. Okay. Yeah. Okay, so you can do the same thing on your calculator. You guys know how to use your calculators? You know the EEs on your calculator? That stands for exponents, right? You want to take the time to make sure you guys know how to use that because you're going to be doing a whole lot of calculations, okay? And so learn it now. If you don't understand it, we have a link under the modules. It'll take you right to it and how to do it. And if you still don't understand it, then you want to talk to your TAs. And if you still don't want to understand it, you come and assault me, talk to me. No, I'm joking. I'm joking. I'm really kidding. No, if you still don't understand it, then you come to me and then I'll show you how to do it, okay? And sometimes calculators, they get into the wrong mode. You want to make sure that they are in the right mode as well, okay? And be familiar with that. It's our, yes, that's right. It's already in scientific notation. Yep. Okay, so when we're talking about numbers, right, in science in general, you always will be talking about what we call the quantity. The quantity is going to be equal to the value and the unit. So everything should have units. It's very rare that you have something that does not have units associated with it. Units will often tell you if you're right or wrong. If you follow the units, they will let you know if you've done the problem right, or they'll let you know if you really made a big mistake. So pay attention to units. Like for instance, if I'm talking about time and I tell you, you need to be here in 90, right? Is that 90 days? Is that 90 minutes? Is that 90 seconds? You don't know unless I tell you, right? And so it's important for you guys to use units. So you don't want to just give me a number because it means nothing. I need the units that go with it, right? So if I tell you, you need to be here in 90 seconds, right? So then you're going to rush to get here, right? If I tell you you need to be here in 90 days, you know, you have plenty of time. You can go get cramped, you can go travel around the world and come back and then be here in 90 days, right? So units are essential. You always want to include your units. Okay, so let's say I want to change my units from 50 minutes to 50 seconds. Okay, so we know that 50 minutes I did. Yes. We know that 1 minute equals how many seconds again? 1 minute equals 60 seconds. So 1 minute equals 60 seconds is what we call an equivalency. They're equal to each other. 1 minute equals 60 seconds. That's always going to be true. So we don't have to worry about sig figs in that situation, because that's always going to be the case. So we don't worry about those significant figures. But the number that we're starting with, we need to worry about its significant figures. How many significant figures do I have here? I have 2. Are you sure? Okay, wait. Hold on. How many of you guys say there's 2 sig figs here with 50? Okay, I have 2, 3 people. 3. Okay, so, and how many of you guys say it's 1 sig fig? Yes, participation. If you don't participate, that means you get an F for my class, right? Okay, I'll ask who doesn't know and it's on the fence? Okay, Colinga, is it 1 sig fig or is it 2 sig figs or is it no, or you don't have a clue?
Kalinga says there's 1 sig fig.
Kalinga says there's 1 sig fig. Okay, Fireball. 1 sig fig, 2 sig figs, no sig figs. Or I don't know. Fireball, no Fireball?
We got nothing.
We got nothing? Okay, so the correct answer is it's 1 sig fig, right? Because there's no decimal here. We're not sure about this number. So it really could be 49.9927, right? That's what it really could be, but we really don't know because there's no decimal here saying that they're sure about that. Okay, so in this case, we have 1 significant figure. There's 2 digits, but there's 1 significant figure. This 0 here is a spaceholder to let us know that it's 50 rather than 5. Okay, so if I was going to convert this into seconds, I multiply it by 60 seconds. And I will put 1 minute underneath, so I keep track of my units. Now, if I have 5 over 5, what happens? 1. If I have x over x, what happens? X over x is x. Okay, if I have x cubed over x cubed, what is it? It's 1, right? So if I have minutes over minutes, what is it? It's canceled out, it's 1. So anytime that we have a number over a number, it cancels out. Anytime that we have a variable over a variable, it cancels out. Anytime that we have a unit over a unit, it cancels out. Okay, so minutes are going to cancel out, and then I'm left with just seconds. How many significant figures should I have? I should have 3 significant figures? Okay. That's right, 1 significant figures. Did I forget anything else?
Unit,
I forgot to put my units. Right, because it don't mean anything unless I have units, right? Okay. Okay, so let's see your skills here. The oldest horse racing track in the United States is the 8-furlong Pleasantation Fairground Racetrack in California. Happened to be in Pleasanton, California. What is the length of the track in rods? So, what am I going to do? Okay, so I'm given the equivalency. Okay, so the way that I believe in setting things up, I always start with what is given to me in the question. So what is given to me in the question? I have 8 furlongs. Okay, then I use my equivalency. My equivalency is, and what do I want to get rid of? I want to get rid of furlong. So I'm going to put that on the bottom since the furlong is starting at the top. Okay, so I'll put my 0.0.
That's what I'm saying. So that's why you punch 40 by 8. But that's the answer.
Okay, how many sig figs? So it's going to be 8 divided by, and that's 8 divided by 0.025. How many sig figs should I have? So the answer, I'll write down what the answer is. I should say, I'll write down. So it's 320 rods. So how many sig figs do I have? Are you sure? Are you sure? So if I have 1 sig fig, so this is not the correct answer. If I was talking about sig figs, keeping track of sig figs, my answer would be what? I'm not talking just about scientific notation. I want 1 significant figure. This here is 2 significant figures. That's 1, that's 2 significant figures. So you're saying it'll be 3 times 10 to the 2. So that would be the correct answer. That would be, and then you put rods. Or I could just say it's 300, right? So your answer, okay, because we're not sure about that 8. So this 8 here, we're sure about. We know that that's 8, but we don't know if this is 8.111111 or if this is 7.999999. So we're not really sure about these numbers here. So when you're doing significant figures, you have to go with the number of significant figures you're starting out with. Your answer should be the number of significant figures you're starting out with. This is an equivalency. This isn't going to affect the number of significant figures. So in this case, we're only sure about that 8, but we're not 100% sure about that 8 because really it could be 7, because if we have 7.65, that's right. because that 8 could be rounded, right? It could really be 7.65, right? And if it's 7.65 and we multiply it by that, well, but see, it sounds intangible. But what happens is that you'll be collecting data from so many different sources. Like for instance, we'll have a scale that is it only goes to 0.1. But like, remember the very first experiment that you guys did, you had to weigh. Well, not the Mentos one, the baking soda. You guys remember the baking soda? And your scales were all different, right? And some of them went to 0.00 and some of them went to 0.0. Because of that, we have to take that in consideration, right? Because if yours goes to 0.00, it's more accurate than the one that just goes to 0.0, right? So because of that, we take that in consideration. And that's the reason why we have to use significant figures. So what you're saying is here, the answer with significant figures would be 300, right? This would be the answer just doing calculation straight, 320. But if we're talking about sig figs, we need to say 300 because we're saying we're not really sure about that 20. It could be less or more, but by us leaving it alone like this, we're saying we're not 100% sure about that. We just know that this first number is going to be, and that's it. Okay. Don't worry, I'll get into it a little bit more in detail. Okay, so we've talked about equivalencies. Equivalencies is just saying, 1 second, 60 seconds equal 1 minute, right? So those are equivalencies. They're also what we call conversion factors. They allow us to convert from one unit to another unit, right? So 1 day is 24 hours. That's an equivalency, is it not? So this allows us to write our equivalency any way we want to. We could put 1 day over 24 hours, or we could put 24 hours over 1 day. So if I tell you my car averages 17 miles per gallon. So I can invert that. I could put 17 miles over 1 gallon. I'm not going to put 17 gallons over 1 mile because that doesn't mean the same thing. Are we clear? Yeah. Okay. So you always want to make sure that you're using units. I always say start off with what you're given. Your given part first. Then you're going to use your equivalency to figure out what you need to get rid of, because you always know you need to get rid of something to convert to something else. Don't fall asleep on me yet. It's still early. I still got what, 3 seconds or something like that? Let's see. I have 9 seconds. Don't fall asleep yet. 9 minutes, not 9 seconds. See, that's why units are important, right? Okay, so calculate the number of weeks in 672 hours. So what am I going to start off with? My given. Okay, I have 672 hours. And how many hours are in a week? So I don't know how many hours are in a week. 168. Isn't there an easy way of doing this? Can I just break it down to make it easy for me? Because I'm not as smart as you are. I can't do all that math in my head. Okay, so how many hours are in a day? Okay, so there's 24 hours in a day. So I have 24 down here because I want to get rid of hours. And then how many days in a week? You just told me how many? Is that 7? Okay. One week. So 672 divided by 24, and then you divide that by 7, right? So Okay, so here's the question. How many sig figs should I have? I should have 3 sig figs. So So 4.00 weeks. So that tells me I have 3 significant figures because I put the decimal here. Now I have 4.00 weeks. Are you with me? Yeah, you guys are not, but we'll pretend. We'll pretend. There are space holders under certain circumstances, but they're also, because we put that decimal there, now they become significant. Yes. That decimal tells us we're sure about this. That's right. Yes, the number that we're starting off with here has 3 significant figures. These are conversions. Conversions are not going to count for significant figures. Okay? In other words, you multiply it 24 times 7. Yeah. Yeah, you could do that if you're familiar with that. But I always like to do it stepwise because when I try to do a lot of stuff in my head, I screw up. Okay, so what distance expressed in miles will an automobile travel in 3 hours at an average speed of 62 miles per hour? So what is my equivalency here? And what is my given? Are you sure that's my given? Or is that my equivalency? So 3 hours is my given. I'm going to be traveling for 3 hours. Now, my equivalency in this case is 62 miles. $62 miles per 1 hour. So then hours are going to cancel out and we're left with just miles. $186 miles. Okay, how many sig figs should I have? I should have 1 sig fig. So what would be my answer? So it'll be 2 times 10 to the 2. Or 200. Okay, piece of cake. Okay, let's see. What did we do? I got 3 minutes. I'm going to use it. Okay, so a little girl broke her piggy bank. Inside, she found 2,608 pennies. How many dollars will she have? So my given is 2,608 pennies. Okay. So $1 is 100 pennies. Are you sure? Okay, I want you to be my boss. You can fix my check anytime you want at that rate. 1, 2. Yes, it's gonna be $26. Now, how many sig figs do I have? I have 4 sig figs because that 0 in the middle always is gonna count. If I wanted it in scientific notation. Yeah, if I wanted it in scientific notation, you would. Yeah, yes, you would. And then that way you'd have to say times 10 to the, 10 to the 1, yes. No, you do not always have to write it in scientific notation. The only time that you will have to write it in scientific notation that you have to is if it's asking you specifically to write it in scientific notation. Okay, questions, concerns, Cash, Kool-Aid. Oh. No, it didn't say scientific. We did. You had the option. You could write it either way. And actually, we wrote it the other way as well too. Okay, I will stop right here. We will pick this back up on Monday. We will have class. We will have lecture on Monday. Okay, I'll try to keep it short and brief. We're gonna have to finish this chapter, but you guys have to work with me. Okay. Okay, I will see you guys on Monday. Have a good 4th of July. Don't get rocket out. Yes. Don't go to Vegas and buy illegal fireworks.